So, last section 5.1 we basically looked at expressions with integral exponents, and now we're simply going to extend our work with exponents to include rational exponents, rational numbers, which is an integer over an integer. So if I look at 3 to the 2/3, 2/3 can be written as 1/3 times 2 or 2 times 1/3. And we then know we can write this expression 3 to the 2/3 two ways. The cube root of 3, the cube root of 3 squared, or the cube root of 3 squared. So 3 to the 2/3 can be expressed in 3 different ways, and you should be comfortable, going back and forth amongst these. In general, if I have something like 7 raised to the 1/7, that's the 7th root of 7. And if we look, for example, at 5 raised to the 1/2 power, if we use our rule of exponents from the last section, 5 to the 1/2 raised to the second is 5 to the 2 times 1/2, or 5 to the first, which is 5. So something squared is 5, well then that 5 to the 1/2 has to be the square root of 5. And indeed, that follows and is consistent with our rule of 7 to the 1/7 is the 7th root of 7. So 5 to the 1/2 is the second root, or the square root of 5. And note, it's not common for us to write a 2 here. The square root, it's implied that that number right up here is a 2 if nothing's written there. So a whole bunch of examples here. 4 to the 1/2, we recognize this the square root of 4, and it's the positive, the principal square root, since we have nothing written here, which means it's positive. So I'm looking for the principal square root of 4, and that simply is going to be 2. If I have for 4 to the negative 1/2, I'm simply going to view that as 1 over 4 to the 1/2, so that's going to be 1/2. 4 to the 3/2, I can split that up a couple ways. That's either 4 to the 1/2 cubed, which would be 2 cubed, which would be 8, or I could look at that as and I guess that's, if I look at it another way, it's not really going to help me. Let's try it out. How about if I look at it as 4 cubed to the 1/2 power? 4 cubed is 64. Square root of 64 is 8, so I could look at it either way. 4 to the negative 3/2 down here, next one. 1 over 4 to the 3/2. We just did 4 to the 3/2, so that's going to be 1 over 8. Now, negative of 9 to the 1/2, I want the negative square root of 9, so that's going to be negative 3. And the last one here, if I'm looking at 3 to the 1/2 times 5 to the 1/2, that's 15. 3 to the 1/2 times 5 to the 1/2, 15 to the 1/2. Quantity squared, and 1/2 times 2 is 1, so that simply is going to be 15. Going to be asked to solve some equations where I'm looking for solving with my variable up in the exponent. And in this case, I want to use the idea if I've got 3 to the m equals 3 to the n, then m will equal n. So in this case, I can write that 9 as 3 squared to the x equals 3 to the 5th. 3 to the 2x equals 3 to the 5th. Therefore, 2x equals 5, x equals 5/2. And I can always go back and check that out. I could plug that back in and check and make sure it's going to work. 9 to the 5/2 equals 3 squared to the 5/2, which equals 2's will cancel 3 to the 5th, and indeed that answer checks. So if I've got a fraction here, 9/25 raised to a negative exponent, what I'm going to want to do first is probably eliminate the negative exponent aspect of things. So this would be 1 over 9/25 raised to the 3/2. Invert and multiply, that's going to give me then 25/9 raised to the 3/2. So what I've got is, if I have a negative exponent up here, fraction raised to that negative exponent, all I can do is reciprocate the fraction, and then that causes the exponent, or that's equivalent to having that exponent become positive. So then you can go ahead and solve. I'd be looking for the square root 25/9 square rooted, and then go ahead and raise that to the third power. So that would be 5/3 raised to the third power, or 125/27. So let's look at an application of exponents, exponential growth here. Thinking back, we did some simple interest problems looking at an annual interest rate. Let's suppose I have something that's worth $250. 8 years pass, I know it's then worth $362. What's the approximate annual rate of increase? And so I can set that up, my initial 250, x raised to the 8th, and I don't know what my multiplicative factor here is, will be 362. For example, if my rate of increase were 7%, x would be 1.07. If it were 11%, it would be 1.11. But we don't know what x is. So the question is, we got to solve for x here. So how are we going to do that? And the answer is, first of all, I'm going to divide each side by 250. And then I'm going to take the 8th root of each side. So that's going to be x is 362 2/50ths, 1/8 root. I'm then going to go grab my calculator and get that answer, which is about 1.0473. So then my annual rate of increase is going to be about 4.73%. Make sure you can do that with your calculator. Make sure you're using parentheses properly when you go ahead and evaluate each of these in your calculator. And remember, your exponent key is going to be that caret, which is right above your division sign. Okay? We're going to continue to look for quadratic patterns when we're asked to solve things. This is on page 180. This is number 56. I'm seeing that here I've got a 4/3 and a 2/3. So the first thing I'm thinking is this is an x to the 2/3 squared minus 6 x to the 2/3 plus 8 equals 0. So if I let x to the 2/3 equal u, I then can rewrite this as u squared minus 6u plus 8 equals 0. That'll factor into u minus 4, u minus 2 equals 0. And at that point I can go back in and look at, say, x to the 2/3 equals 4, or x to the 2/3 equals 2. And continuing along here, that then, if I want to solve for x, I'd raise each side here to the 3/2 power. X to the 2/3 to the 3/2 equals 4 to the 3/2. So x equals, let's see, the square root of 4 is 2, 2 cubed is 8, or, same thing here, x to the 2/3 raised to the 3/2 power equals 2 to the 3/2. And then I've got x equals, let's see, 2 root 2.